We know the grid is undergoing massive change, which creates massive opportunities for local energy. The Energy Changemakers podcast offers rich conversations with industry leaders to help you and your company capture opportunities to build the decentralized grid. I'm your host, Elisa Wood. Welcome to the Energy Changemakers podcast. Hey everyone, Elisa Wood here from Energy Changemakers. I was fortunate to recently catch up with Bruce Nordman just after he retired from a 40-year career as a research scientist at the Lawrence Berkeley National Lab. He left his job with some really interesting insights about the electric grid and what ails it. In essence, he says, we've created a system that makes the electric grid, not the electric customer, the priority. He has some pretty clear ideas about how to fix that, which he talks about here. Hope you enjoy the show. So, hey, Bruce, it's so great to have you with us today, especially at this time. You are just leaving a spectacular near 40-year career at the Lawrence Berkeley National Lab. I want to talk to you today because I'm really curious about some of the takeaways you have after that kind of career, what you're thinking about. Tell us a little bit about the work you've been doing at the lab. Let our audience know what you've been up to.
Yeah, so I started there in the mid 80s. Oh, and first off, thank you so much for this invitation. And I'm a great fan of you and the podcast. So this is a very welcome opportunity. Early on in my work there, I settled on energy use of electronics as an area to focus on. So it'd be things like computers, printers, televisions, network equipment. And this was a new area of work. So it's an area that I could contribute new ideas to and help be an innovator in, as opposed to other areas that were already well established with experts already there.
And 40 years ago, electronics was looking very different than it does now.
Yeah, it was dominated by desktop computers, which of course used a lot more energy than the notebooks we have today. So that was certainly a very welcome efficiency gain. But for IT devices, being connected to a network can strongly influence how much energy they use. So my work there then naturally led into looking at IT network technology and how that intersects electricity use and consumption and efficiency opportunities. And another thing that did is it brought up the area of technology standards. And as the public sector, being at the University of California and working for government agencies, we don't make or sell anything, so we can influence the market through mandatory standards or through influencing the technology that gets put into products, such as communication technologies.
So that's how you were spending your Monday through Friday working on those issues. So it was almost 40 years that you were with LBNL. I'm really curious kind of what you walked away with thinking about. What were the lessons and conclusions you've reached? What's going on in your mind when you think back to those years?
There's one evening in January of 2010, and some ideas have been brewing in my mind, and I realized how we could actually network electricity itself. And I woke up the next morning and realized that the rest of my career would never be the same after that day. It was a very strange feeling to have, but it was true. Trying to sort of develop the technology, the principles, get it established in people's heads as ideas and in technology standards, and then ultimately into products and hopefully into tariffs and regulation and policy and extend that out. So that was a pivotal moment in my life.
And when you're talking about networking, you're talking about networking within a building.
Yeah, so I've been a buildings person, and so I try to restrain myself from drawing a lot of conclusions about how the electricity grid should operate internally, but I have a lot of opinions about the technology inside of a building or between adjacent buildings and how the customer relates to the utility grid. And those need to be really globally standard because products are shipped globally. And so if a product is going to work, it has to be able to work wherever it lands. And we do that with IT products today, where you expect a computer or a printer to work in any country, any building type. And we need electricity technology to have the same characteristics.
So can you give me an example of where it does not have that? What's going on in the building where we're not networking devices correctly?
When I say let's talk about networking electricity, so the old phone system and the electricity grid we have today are one large unitary system. And that was the best that we could do in the 1880s when both technologies were invented. With communications, over the last 50 years, we've thrown away the phone system, both in terms of hardware and critically the technology, infrastructure, and ideas behind it, and replaced it with something much better, internet technology. And we can and we should do the same thing for electricity to transform our technology to something based on different technological principles. That instead of being part of a unitary system, electricity is divided into domains of power that are managed separately, yet can be connected to each other in a way that's analogous to how on the internet networks, both inside of a building and the network of the building itself being connected to the wider network of the internet, all can operate both autonomously and connected to each other, as opposed to
Hmm.
one large unitary system.
Interesting. For me, as the person sitting in the building, do I know the difference?
Ideally not, because we really want this all to be invisible and operate automatically behind the scenes. But it
Hmm.
means that if you buy a new electrical appliance, you should be able to plug it in. It should automatically connect to your local area network, find a local price server that has the price of electricity for the building, automatically start getting those prices and optimizing to them with zero involvement of the user. It should all be built in and automatic the way so many things are with IT products. Today, you have to have complicated arrangements with your utility, with third-party aggregators, with the product manufacturer, configure things. Demand response programs are constantly changing. It's chaos. It's different in every utility, different in every country. It changes over time. And the best things in life are simple and universal. Email, web browsing, USB. We need to make electricity have those same characteristics.
That is so true. And it's what makes so many new technologies frightening, I think, to people like microgrids. You'll hear companies say, I don't want my life to become more complicated. I've got enough to deal with. I don't want to deal with a microgrid. Or even simpler, the customer who buys an EV and they're hearing about vehicle to grid and pricing and all these different things. And they're saying, I just want my life to be simple. I don't want to have to deal with all that. It seems like in the electricity world, when we bring on innovation, we often ask the consumer to take on new burdens, more work.
Yes, and so much of those burdens is not necessary if we had the right technology and the right policy. So it turns out the vast majority of us already own a microgrid because by the Department of Energy definition, a notebook computer is a microgrid.
I've heard you say that before. I love it. Yes, explain.
So the definition of a microgrid is an electrical system that can operate either connected to a larger grid or autonomously. And of course, in order to be a grid, you have to distribute power to devices that consume power. So a notebook PC can operate connected to the grid, or you can disconnect the power source and it can operate islanded. And it's a grid because it distributes power to attached USB devices. Now, the amounts of power are very low, but most technologies start out small and then get scaled up. The first airplane was one person for 12 seconds for 80 feet, and now we have jumbo jets to Dubai. So we know that's how most technologies work. So we need to build on success, take these mechanisms that work and scale them up. Now, one reason this works is because USB power is digitally managed. When you plug a device into a port, it doesn't just get power, it has to request it from the computer. And there's communications to discuss how much capacity is available, what voltage do you want, etc. And that capability allows you to do things that are fundamentally impossible without digital communication.
Very interesting. Another thing I've heard you say that I want to ask you about is that virtual power plants, which of course have become very popular and everybody's talking about them in the electric field. You said virtual power plants treat customers as power plants. What does
Yes.
that mean?
So it's sort of natural for a utility grid operator to want to use the tools that they have available to them today. And flexibility is today managed in wholesale markets with generators and then with grid scale batteries and BPPs. So it's natural to want to sort of extend that tool more and more as if customers were power plants, but they're not. They have different characteristics, different behaviors, and different desires, and they're customers. And so often, people who run the grid forget that the grid was invented to serve customers, not the other way around. So what we really need to do is determine what customers and customer devices want, and then design a grid that serves them, which is the opposite approach that people usually take.
It is so the opposite. We hear a lot of talk about the value of these new technologies like virtual power plants, microgrids, et cetera, the value that they bring to the grid, that they can serve the grid. And really, they're supposed to be, especially a microgrid, is supposed to be a customer product. So it's odd that we've switched it around and made sort of this almighty grid that we're all trying to serve. What do you think it will take to like turn that thinking around? Is it even possible?
Oh, I'm an optimist because I think there's no other workable choice other than to be an optimist. But I think the main barrier we have is inside of people's heads. It's not a technology problem. We have the technologies available today to do just about everything we need to do. We just need to get people to realize that that possibility exists and to then start using it and to scale it up. And it's going to take many years for it to happen, to introduce pricing in more places and other grid coordination mechanisms, and also to drive global harmonization. But I certainly believe we can achieve it. We accomplish something arguably much more complicated with internet technology because communications is a lot more complex than electricity in many ways. And we've already done that. So we just need to learn from history.
Right. And I guess a lot of people would say, well, one of the problems is that we have utilities and utilities have always done things a certain way and it makes it harder to bring about these changes.
Yes. So one thing we've forgotten how to do with electricity is to throw things away and forget,
Huh.
because that's really quite essential. Every night when we go to sleep, part of what we do in our brains, as I understand it, is to figure out which memories to keep and which memories to discard because there's more that you experience than you can actually retain. And as the technology for electricity changes, the policy and the regulation also need to change because they're designed around the technology. And we need to do a lot of acceleration and changes in all of those to adapt to the possibilities that the technologies that exist today already present. So, as an example, we use prices in wholesale markets, we use prices at the meter, we can have what I call local prices inside of buildings, and you can send power over an Ethernet cable to power camera, a Wi-Fi access point, or other devices. And you can put a price for the value of the electricity on that cable, not according to an application layer protocol, but according to the Ethernet standard itself. The difference in electrical capacity from that wire of that Ethernet cable to the wholesale market is a factor of a billion. It's 9 orders of magnitude. And I challenge you to find any other mechanism that can operate seamlessly over 9 orders of magnitude. And I believe the price is the only mechanism that can do that.
So, where do you see us going with pricing? What's the ideal kind of situation?
So the concept of time of use pricing is widely understood and popular and used all over the world. And that's, of course, much better than having flat pricing. But that time of use is designed for people to look at the prices and then make manual decisions or set timers and such to respond to them. But
Again, we're putting the burden on the consumer.
exactly. And people don't want to spend time thinking about electricity. This is my job and I don't want to do it. I have other things to think about. But we can have devices that automatically look at the prices and make the right decisions to automatically save us the most money.
And that technology does exist now.
Yes. So what this relies on is something that I call highly dynamic prices, which is basically hourly prices that are different every day. Now, the intervals could be smaller than an hour, and maybe they will be in some places. They'll certainly never get faster than 5 minutes, and maybe they'll never get past half an hour or 15 minutes. It doesn't really matter because the automation doesn't care about that kind of thing. The main thing is to start with hourly, and then we can worry about what happens after from there. And if the prices are not different every day, the wrong price because conditions on the grid are different every day, so the prices need to be different, just like airline ticket prices are different every day because the supply demand conditions are different.
Yeah, that's interesting. And I'm trying to think of this all from the utility perspective too. I know you said that from the utility side, they don't need to look inside the consumer box, basically, inside the building. They don't have to know what's going on. They only have to know what's going on at the meter. But I'm imagining their arguments to that, right? If I'm a utility, I might be saying, well, if I don't know that they have a fleet of EVs, I'm not going to know how that consumption at the meter is going to change over time or at a time when it's important to me. How do you address that?
Yeah, so if the utility today is trying to decide what's going to happen on August 3rd, 2032, they of course have no idea. But on August 2nd, 2032, they'll see what happened and they'll know what happened the day before, the day before. So we will have years of history to look back on to understand what's likely to happen tomorrow. And this is how airlines work. They look at the history of how people select airline tickets and use that to guide how they change prices to balance supply and demand of airline tickets. And they've learned to do that very well to meet their needs. And I'm confident that
Mm-hmm.
electricity operators could similarly do this very well because they'll again have this years of experience of all of the meter readings for customers in a very granular sense.
Right. History tells you a lot. But what about the argument that, hey, things are changing fast, that people are using new kinds of devices, that we have electric vehicles now? I mean, are things changing so fast that history would not serve as a good proxy?
Well, again, if you're trying to decide what prices to charge tomorrow, you know what happened today and yesterday and last week and last month. And so you can bring all of that information to bear, in addition to the information that already is used to operate grids, such as weather and calendar and such, and wholesale prices, in order to feed into deciding what the best retail prices to charge. So I think that's a very solvable problem because there
Got
is
it.
so much data.
Makes sense. That makes a lot of sense. So, in your years of doing this, who have you found has been receptive to this notion that we need to work more from the customer side? And who have you found has resisted it?
Well, in terms of being receptive to it, there's actually millions of people around the planet today paying such prices, and they switch to those tariffs because they result in lower bills, including most people in Scandinavia. And customers are fine with such prices if they result in lower bills. And once you have the prices, then people have an incentive to adopt automation to use them to lower their bills even more by reducing system costs, because that's the only way you can reduce bills is by reducing system costs. And there's three ingredients to making this work. You have to have the prices exist. You have to have the communications infrastructure to move those prices from the grid to the customer site. And then you have to have the devices that can use the prices.
So there are places in the world that have those three, and there are places that do not.
No, actually, no place has all three. So in Scandinavia, as an example, they have the prices, but they have very little in the way of automation. They have some companies that do, but they don't have, for example, price servers that make the prices easily available, and they don't have in-building automation to use the prices. In California, we've thought a lot about the automation, but we don't really yet have the prices. And in Australia, they've been working on distribution system capacity management, coordinating between the grid and the customer, but they've done very little on the price front. We need to put them all three together. And then once you have the prices and the communications infrastructure, then manufacturers will have an incentive to produce products, often through a software upgrade, to then have prices be able to be price responsive.
Interesting. And talk a little bit about distribution capacity management and what they're doing in Australia. That's pretty interesting.
Yeah, so what they discovered on an increasing number of feeders is that they were a few hours a year reaching their limit for how much power could flow through the wires and transformers. So they had to say, okay, on this feeder, nobody else ever gets to install more solar, which a lot of people were unhappy with, even though 99% of the time there wasn't a problem. It was only a few hours of the year. Or they could spend money they don't have in transformer supply chains that didn't exist to increase the capacity just for those few hours. So instead, each day they broadcast out on those feeders to the solar customers a set of limits for intervals of time for the maximum they can export. And so if a customer, and this allows the grid to make full use of the capacity that's there while guaranteeing to the utility that they won't damage equipment. And then if a customer is in danger of having to curtail their PV to not export too much, they can instead shift load, which is what we would like them to do anyways. And so it's a real win-win for everybody.
Yeah, this is fascinating. So knowing that no place in the world has all three elements, say you're made king of the United States tomorrow, what would you do? Where would you get started to bring these three elements together in the US so that we had more customer-centric pricing?
So first, I would say that every electricity customer should have the right to choose a tariff that has these characteristics, that's at least hourly and different every day, and that they can save money on. And each utility should be required to have a price server that announces those prices electronically or Open ADR3 protocol, so that then customers could have devices that can then receive and use those prices. So that's the main thing to happen. And once the tariffs are available, again, companies will have an incentive to make use of them, and then the market can take it from there. But without the prices, you really can't do anything.
That's key. Yeah. Interesting.
Pricing plus the automation so that it can be, because again, we don't want people looking at prices. They're not interested in it. They wouldn't be good at it.
Right. We need the automation in there. We don't want people to have to try to figure this out because they just won't. It won't happen. Yep. There'll be a few, but not most people.
If maybe 1 to 3 days a year when there's an emergency situation, have people look at prices, that's fine. But most people aren't going to want to do it more than a few fingers on a hand days per year.
Yeah, I think that was a big mistake maybe about a decade ago. And there was a lot of thinking that smart meters or smart displays were going to be in our home, and we were going to constantly watch the pricing, and we were going to not do the laundry and all these other things, based on what the price of electricity was. And I think generally that kind of went out the door.
It reminds me of watching paint dry.
Exactly. We're interested in power and we don't want to do that.
Exactly.
Yeah. I want to hear a little bit about what's next for you. This has been a very interesting career you've had. You're walking away with some ideas that are incredibly important right now to the electric grid, to those of us who are being served on the electric grid, everybody. What's next for you?
Yeah, so I plan to do some consulting and some pro bono work to advance these concepts, and also spend more time doing things other than work. But as I mentioned, one essential part of this is global harmonization. And as we know from our experience with information technology, this is possible, and that's the way we will get success to have the lowest prices on products and the most interoperability, is if the technology is the same everywhere, which we know from things like USB and Ethernet to distribute power. That's possible because we own devices today and have for decades that do distribute power and coordinate it digitally on a globally harmonized basis. And we need to just extend that to all electricity using devices and infrastructure devices like batteries, so that we can make things as simple and as plug and play as possible.
Sounds good. I'm all for it. Well, thank you so much, Bruce. This has been a great discussion. And I hope you come back in a year or so after you have been doing this new work out there consulting, and let us know how it's going.
I would love to do that. Thank you.
Thank you for joining us today on the Energy Changemakers podcast. I hope today's conversation has inspired you to think differently about the role of distributed energy in our society. If you enjoyed this episode, please subscribe to our podcast on your favorite platform and consider leaving us a review. You can help us shape the dialogue around energy. Go to energychangemakers.com, subscribe to our newsletter, and join our community. Together, we can make a real difference in how quickly we can make our grid local, equitable, and clean.